This is the second half of Chapter 8. Chapter 8 in the beginning was about combining, and now the second half of Chapter 8 is about breaking apart. The first section is 8.5, using the distributive property. So normally you use the distributive property to multiply a monomial to a polynomial, and we're just going to recall that by actually distributing. Now we want to go backwards. We were going to give you something like this, and I want you to give me this. Or you're presented with this, and I want this. Okay, you can work backwards to express a polynomial as a product multiplication of a monomial factor and a polynomial factor. This process is called factoring. Steps to factor a polynomial uses the greatest common factor. You find the GCF of each term, you divide the GCF out of each term, and you place the GCF outside of the parentheses. Then place the remaining terms from step 2 inside of the parentheses. So for instance, our GCF here between 3a and 6, our GCF is 3. So this is the same thing as 3 times what? I'm going to remove a 3 and a 3, and I would get a plus 2. The beauty of math is you can check your work. 3a plus 6. Yep. Okay. Try these on your own or watch a few of mine, pause, try them, and then watch for the answers. For part B, 4x squared y minus 8x, they share between them the number 2. They share between them an x. So this is the same thing as 2x times what? So remove a 2x from each term. Then we're going to get 2xy minus 18 divided by 2, 9. The x's simplify. So let's check. 4x squared y minus, yep, that works. Here we're going to factor. We see they all have an m, they all have a 2. So take 2m out. What's left over? I'm going to remove 2m from each. We get a 2m squared plus m plus 3. Like I said, the beauty of math is that you can check your work by multiplying and seeing if it's the original. We're going to factor this trinomial. We see the number 4 is in everything, x is in everything, and y is in everything. When I remove a 4xy from each term, what do I get? I get 2x cubed, or squared. The y simplify. 4 divided by 4 is a 1. You can write 1, you don't have to. X, the y simplify, minus 24 divided by 4 is 6. The x's and the y simplify. Like I said, if you've just been following me, maybe try pausing the video and doing this on your own. They don't share any numbers the same, but they both have a g, and it's how many do they all have in common. They only have one g in common. They have 2 h's, 1 h. So it's how many do they have in common. So take a gh out of each term. You're going to still have 10, but then you're going to have a g and an h left. Oops. Take the DH out. We're going to have 10 GH plus. The 9's still there. The G's go away. There's still an H minus. Still a G. H's cancel. Here, there's a 5. GCF is 5. C squared, C squared, C squared. They all have C squared. V, V squared, V cubed. They all have a V. So divide by 5c squared v. 5c squared v, 5c squared v. You're going to get the 5 simplify, the c simplify, the v simplify. So anything divided by itself is 1. So you're going to get 5c squared v times 1 minus 15 divided by 5 is 3. C squareds cancel. V squared v plus 5's, c's, can be 2 v's left. And that's it. Okay. The GCF here, here's a term and here's a term. They're not as small as the GCFs here. What these two things have in common, their GCF is a 2 plus n. So I take a 2 plus n out, and when I multiply, what's left? So take a 2 plus n out, take a 2 plus n out, you're left with n plus 5. Same thing over here. The GCF isn't just a small number like 5. The GCF here is a quantity. It's a quantity of y plus z. So remove the quantity y plus z from both, and you're going to get an r minus s. So I have y plus z as the GCF, and I'm left with r minus s. Okay. Now I want you to try some of those on the back. So pause the video, try 15 through 24, and then see if you're correct. So there's y plus 1 in both. When I remove it, you're left with y plus 2. I have a c plus d in both. When I remove it, I'm left with 3 minus a. I have an x plus w in both. When I remove it, I'm left with a 2 minus c. I have an x minus 2 in both. Then I'm left with a 6 plus y. But also there's another a minus b. There's an x minus 1, but technically there's a 1 right here. So it's 7x plus 1. There's an r plus 1 here. And then what's left is an mn minus 1. That's it. It says using the distributive property to factor polynomials with 4 or more terms is going to be called grouping. So we're going to find a method of when you don't have a GCF. Like here, there's no GCF, but we're going to use grouping to make this polynomial look like these polynomials to find a GCF to factor. So here I have no GCF, no GCF. But if I look and group these terms and I group these terms, we have GCFs between. Here between these two, I have n, and then I'm left with p plus 2. Between these two terms, I have a positive 8, and then I'm left with p plus 2. Why I group is so that I get the same thing twice. So I can say, okay, now I have a GCF of p plus 2. When I do that, p plus 2 is multiplied to n plus 8. Same thing over here. There's no overall GCF. We'd say, oh, x, but these don't have x's. We'd say, oh, 7, but this doesn't have a 7 in it. So you group the first two, you group the last two. In between these two, there's an x, and you're left with y minus 7. We want a y minus 7 again. This is a plus, so to make it a negative y plus 7, I need to remove a negative 7. If you removed a positive 7, that's okay. You just have to go back and change it because you'll realize it'll be y plus 7. So here, you're going to get a y minus 7 taken out, and you're going to be left with an x minus 7. Now we're doing this because factoring is a way we're going to be able to solve here in a few sections. So the purpose of factoring or breaking apart is so that eventually we can solve equations that aren't as easy to solve. Here, there's no overall GCF, so we just take a GC out of the first two terms, and then we group the last two terms, and we want an a minus 4, so we take out a positive 6. Now we have a GCF of a minus 4, and what's left is an a plus 6. The second half, in between them, we have a 2u, and we're left with n minus 4. Between these two, I want an n minus 4 again, so we take out a negative 3. N minus 4, 2u minus 3. And lastly, try these on your own. Between these two, I have a 2x squared. That means I have x left. Move 2, you're good. Between these two, I want x minus 2 to be left, so a positive 3 was taken out. I have the same. When you take the x minus 2 out, you're going to be left with a 2x squared plus 3. Okay, last one. No overall GCF. I group the first, take out a 3p, and I'm left with an n plus 5. I group the last two. I want an n plus 5 again. That means I have to take out a negative 4. Now I have a GCF of n plus 5. So I take the GCF out now, and I'm left with 3p minus 4. And that's it. Okay, we're going to eventually be using these to solve, but these are baby steps. We have to factor and really know how to factor before we can solve.